Hello, everybody, and welcome to your Section 3-2 walkthrough. This is about cross products, and you can go ahead and read that paragraph up at the top if you want to, but basically, cross products, we love cross products because it's a shortcut. Okay, what I taught you in the first section, how to solve proportions, cross products is a way of immediately getting rid of the fractions in a proportion. The number one thing we don't like to have in an equation is fractions. So everybody loves this section. Every year I go through this and the students are like, oh my gosh, Mr. Schaub, this is great. This is where they really start appreciating what the previous mathematicians have done for us, okay? So just real quick, if you look at the key concept example here, okay? So let me get my calculator out. First off, we have this equation that says 3/4 equals 6/8, and we can verify that. If we do 3/4 on the calculator, we get 0.75. If we do 6/8 on the calculator, we get 0.75. Remember, there's infinitely many fractions we can make that equal 0.75. So there's lots of equivalent fractions. So somebody way back in the day realized, hey, since we can do whatever we want to both sides of an equation, let me use purple here. If we multiply both sides by 4, then these 4s will cancel out. And if we multiply both sides by 8 times 8, then these 8s will cancel out. And so what are you left with? We're left with 6 times 4, and since that 4 is gone, we're left with 8 times 3. So cross products is an even shorter way of doing that step. Okay, that's how you get rid of fractions in an equation. If you multiply everything by the denominator, the factor cancels out the denominator and you get rid of the fractions. So the shortcut is, and I'm sure a lot of you have seen this before, you circle your cross products, okay? And of course, the word product makes us think multiplication. So we take the cross products, we multiply them, and we set them equal. Okay, so you can see 4 times 6 is 24, 3 times 8 is 24. That will always happen. If I just come up with two equivalent fractions real quick, 1/2 and 5/10. Okay, we've got 2 times 5 is 10, 10 times 1 is 10. So that's what we're doing here. We're multiplying the diagonals together and we're setting them equal to each other. And that is always a true statement if the two fractions are equivalent fractions to start with. Okay, and then real quick, I'm going to make this video as quick as I can because it's just a shortcut. Once you learn the shortcut, it's solving equations, and you guys are good at solving equations. Some of them are going to be pretty complicated, but we've got that graphic organizer that we got in section 1.4. You can just go through the steps, okay? Ask yourself those questions. Do I have to distribute? Do I have to combine like terms on one side or the other? Do I have variables on both sides? Okay, and then once you take care of those 3 steps, you got a 2-step equation, and you guys are pros at that. So let's take a look. So real quick, I'm going to show you guys this anyway, because if I was in class, everybody would think it's hilarious. So it says B cannot be 0 and D cannot be 0. Then AD equals BC. So that's kind of what we're saying. We're going to multiply A times D and set it equal to B times C. Okay, and why are B and D not allowed to be 0? Well, there's 3 things you can't do in math. You can't divide by 0. Okay, that's one. If you try it on the calculator, if you do 4 divided by 0 and hit enter, it will give you an error. Okay, you cannot do it. Okay, it's kind of like saying, take these 4 apples and divide them into 0 groups. Well, unless you can make apples disappear, you can't do that. Okay, the other thing we can't do in math, number 2, take the square root of a negative number. It's impossible. There's no number that when you multiply it by itself, you get a negative answer, because a negative times a negative is a positive, and a positive times a positive is a positive. So there's no way you can square a number and get a negative, and therefore there's no way you can take the square root of a negative number. Third thing you can't do in math, especially in my class, you can't give up. And I made these note-taking guides back when DJ Khaled was a thing. You guys might not even know who he is anymore, but I thought it was pretty funny. Anyway, so we're just going to look at a couple examples where we use cross products to get rid of our fractions, and then that will be it. We'll do a couple story problems here involving scale, and then you've got the rest of the packet to get to work on. Okay, so how does it work? So I use some highlighter to kind of show you what our cross products are and how we're going to solve this equation. Okay, so the green ones, I think I color coded the ink too. Oh yeah. See, I know what I'm doing. Okay, so the green ones that are highlighted, those are one set of cross products, and I put first off, because I know some of you are thinking this already, don't overthink it. It doesn't matter which side of the equation you put each cross product. I could just as easily put 27 times 2 on the left over here, and I can move this, and I can put 3k times 3 over here. We'll still get the right answer. It doesn't matter if you get, you know, I don't know what the answer is yet, but 9 equals k or k equals 9. I think the answer is 6 now that I'm looking at it. But yeah, so it doesn't matter which side you put them on. Okay, you can put them on either side, you'll get the same answer. So we just, in this one, this is pretty simple. We just multiply both sides. So we get 9k equals 54. Then once you've got it simplified, your equation solving skills should take over. Okay, now the goal is get the variable by itself. So the only thing, this is a one-stepper. The only thing we have going on here is k is being multiplied by 9. So we divide both sides by 9. Okay, cross out if you want. And then we get k equals 6. Okay, and like always, you can check your answer. I'm only going to do this once, but you should do it for every problem you do just to make sure that you're getting it right. So we're going to put a 6 in for k, and then we're going to make sure the two fractions, when we divide them on the calculator, give us the same decimal or the same answer. So 3 parentheses 6, we're putting a 6 in for k, divided by 27, and we get 0.6 repeating. Okay, and then we do 2 divided by 3 on the other side. We should get 0.6 repeating, and look at that, we do. Okay, so we know we got the right answer. Moving on. Okay, now these can get more complicated, but as long as you remember to use parentheses, then you should not have any trouble with it. Like I said, if you put the work in unit 1, it's going to pay off big time in this unit because you're going to feel like a pro when it comes to solving these equations. Okay, all right, so one of our cross products is 7 and x. Okay, so could we write x7? Sure, we could, but we always typically, you know, you want to be organized, you want to be consistent as a mathematician. So we're going to put the number in front, variable second. And then the other cross products, it's a 3 and a 2x plus 5. And you need to treat that 2x plus 5 like it's all one value. And the way we do that is by using parentheses. So as long as when you write cross products that are not just simple, a single number and a single letter, like 27 times 2, I still put it in parentheses over here just to be consistent. And then when it's a sum or a difference, like 2x plus 5, that reminds us that we need to distribute that 3. That's the number one problem I see here is students will look like that and they'll try and skip steps and they'll go, okay, 3 times 2x is 6x plus 5, and they'll write 6x plus 5. Well, that is not what we're dealing with here. You got to multiply that 3 times the 5 as well. So we get 6x plus 15 equals 7x. So if you're looking on your graphic organizer, you see, do I need to distribute? Already did that. Do I have like terms to combine on one side or the other? Remember, here's our center. So no, we do not. The left side, those are not like terms. The right side only has one term. And we cannot just add 6 and 7x and get 13x because where would we put it? On the left, on the right? Both of those are wrong because you can't do that. So we go to the third step. Do I have variables on both sides? Yes, I do. So we got to pick on the little guy. All right. So that means subtract 6x from both sides. That's a 0 and it drops out. And remember, I know I'm going fast, but feel free to pause the video anytime you need. Go back and watch it again. But this should not be anything new to anybody. We're solving equations. We're getting x by itself. 7x minus 6x just happens to be 1x, and so we are done. Okay, could I put a 1 here and then divide both sides by 1? Sure, but it's not going to change anything. The answer is 15, and 15 divided by 1 is still 15. So whenever you can, don't put that 1 there because it just makes you think. And then I see this all the time too, and this drives me crazy. The student will put the 1 there, and then they'll go, well, I got to get rid of a 1, so I'm going to subtract 1 from both sides, and they end up getting the wrong answer because that 1 is not being added to x, so we don't want to use subtraction to solve it. Okay, so don't be that person who puts the 1 there and then that ends up screwing them up. Okay, this is about as complicated as it gets because we're going to have to use parentheses on both sides. Okay, so one of my cross products is 6 times w minus 10, and the other is -2. Okay, so this is a good thing to talk about here. We have a negative sign in front of the fraction. I didn't see that until just now. So see, that's sneaky sometimes because we got that negative sign in front of the fraction. We can either apply it to the top or the bottom, but not both. Remember, if you put a negative on top and on bottom, that's a positive fraction, and this is not a positive fraction. So always put the negative sign with the easier expression. Okay, 2 is much easier than w minus 10. So that's why down here I put the -2, or I'm sorry, I put the negative with the 2 instead of the w minus 10. If you put it with the w minus 10, you're going to have to distribute that negative and change the signs. And you've heard me say it a million times, the more negative signs we have in the problem, the more mistakes we make. Okay, so let's avoid making mistakes. Let's take the easy way out. Apply that negative sign to the side that looks simpler. Okay, and then we have to distribute on both sides. So boom, 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 boom. Just be careful and remember that's a -2. So it's going to change the sign of everything inside. So we end up getting 6w minus 60 equals -8 minus 4w. Okay, so we distributed. No like terms over here. These are not like terms. These are not like terms. And there's my center. So nothing can just jump over that line. So we're going to have to pick on the little guy. All right. So since we have a negative term and a positive term with the w's, the negative is always smaller. So we're going to add 4w to both sides. Okay. Combine like terms over here. So we get 10w minus 60 equals -8. And now it's a two-step equation. Piece of cake. Let's get that w by itself. We're going to add 60 first. Always you're unwrapping the present. So start with the wrapping paper. Start on the outside. Work your way into the middle. Work your way into where that w is. All right. So the 60s cancel each other out. The 10w comes down, and -8 plus 60 is 52. Please use a calculator to do these. That's still the biggest problem I see is, I mean, it's a problem that can be fixed. It's the easiest problem to fix. Just watch those negative signs. They all matter. You know, a lot of students will see this and they'll just do 8 plus 60 on the calculator and end up getting the wrong answer. So make your negative signs really big and visible. Space things out. Don't try and jam everything into a little space, and make sure you don't forget about those negatives. Okay. Then last step, we're going to divide by 10, and we end up getting 5.2. Oh no, I got a decimal as my answer. Is that okay? Of course it is. Okay, and you could check the answer. I'm not going to take the time to do that, but you could plug in a 5.2 on both sides and divide those out, and you should get the same answer. Okay, so you try these two. All right, so I gave you some challenging problems to do here. But you can handle it. Take it one step at a time. All right, pause the video right here and take, 5-6 minutes. Try and see if you can do these, and then play the video and see how you did. Ready? Pause. Okay, I'll tell you guys a joke while you're working on these. My niece, my 6-year-old niece, told me this joke the other day. Why doesn't the princess kiss and tell? Because she has a frog in her throat. I thought that was pretty funny. All right, so let's take a look and see what we've got going on here. All right, first example. You should have gotten negative 17/5, or if I remember correctly, that should be negative 3.4 as a decimal. And remember, I don't care if you leave your answer as a fraction, as a decimal, just get the right value. Okay, so both of those are correct. How do we do it? So you got 7 times d plus 1, 4 times 3d plus 6. We got to distribute both of those, okay? The one thing I do like about this, and hopefully you notice this as well, everything's positive. Oh, don't we love those equations? All right, everything's positive here. And so this is just me kind of showing two steps at once here. So what I did was, here's our center. Okay, so as long as I do the same thing on both sides, notice these are exactly the same. You can do multiple steps at once like this. So the 7d and the minus 7d cancel each other out, and then the positive 24 and negative 24 cancel each other out over here. Okay, so I did pick on the little guy. 7d is smaller than 12d. I just happened to eliminate one of the constants as well, the constant on the other side. So we do the math, and we end up getting 12d minus 7d is 5d. 7 minus 24 is negative 17. And then it's a one-step equation. So we have to divide both sides by 5. Okay, we very briefly think to ourselves, oh no, negative 17 isn't divided easily by 5. But that's okay. Like I said, some answers are fractions, some are decimals. These are your notes, so I want to give you the most challenging examples you're going to see, so you always have an example to look at. The easy ones, you guys are going to do those no problem. You're going to do them in your sleep. These are the ones that we really need to practice. Okay, so I'm not going to waste so much time on this one. This example, you should have gotten 22. Okay, the challenging thing about this one is all the negatives. You got to make sure. This is number one spot I'm going to see mistakes, is right there. Negative 2 times negative 4c is a positive 8c. Okay, don't put two negative signs because that's just going to confuse you later. All right, you should be looking out for those opportunities. Can I make this a positive? In this case, yes, we can. Okay, we always want to make things easier. So you should end up getting c equals 22. You can pause the video if you want to see how I did that one. Okay, scale drawings and scale models. All right, so this is one of the most common applications of proportions, is making blueprints, using maps, building, like set building. If you're doing a play, this is always one story problem I use. If you're, if you have a play set in Italy and you want to build the Leaning Tower of Pisa, obviously you're not going to make the prop the same size as the actual tower. That would be way too big. So you have to scale it down. But if you don't do it right, it's going to look too fat or too short. So that's what scale models are all about. Okay, obviously, if you're making a blueprint of a house and you're putting it on paper, you don't want the piece of paper to be the same size as the house. You want it to be smaller, but so you need to make everything proportional. And that's where a scale comes in. Okay, the scale tells you what to do to every single number in the original house in order to draw it on your blueprint. Okay, so in this case, we're looking at this blueprint of a ranch house floor plan. And the scale is right here, is 1 inch equals 12 feet. And that's really how you should read that. It doesn't really look like an equal sign, it's a colon, but it does the same thing. So basically 1 inch is obviously, not the model, the blueprint, because the blueprint is smaller. So 1 inch is smaller than 12 feet, so 1 inch must be the blueprint. And then 12 feet would be in the actual house. Okay, so every number is going to be every number in the actual house. Like if the garage, if this is 30 feet long, we're going to divide that by 12 feet to get how many inches it should be on the paper. All right. So, and the next thing you got to remember from section 3.1 is when you're given a ratio like this, you can write it like this. And that's what we're going to use. We always want fractions. This is the second time, or no, actually in your class it's the first time, that we actually like having fractions rather than the ratio. The second time that we actually like having fractions is slope, when we're graphing lines in slope-intercept form. We haven't gotten to that yet. We'll get to that next year. But, okay, so we want fractions because now that we know how to use cross products, we don't have to deal with those fractions in the equation. Okay, so next problem. Use a ruler to estimate the distance from Cincinnati to Cleveland. So I went ahead and did this work for you, okay? If you measure that on your piece of paper or on Notability, right, it doesn't. We used to do these on paper, and so this would make sense. I would give them a ruler, and I'd have them measure it. It doesn't make so much sense in Notability because I can make it smaller and bigger, and then it's a different size. But so let's say that on a map, it is 4 centimeters from Cincinnati to Cleveland. Okay, so the first thing we're going to do when we do a story problem is we're going to set up our ratio, and we're going to write it out in words. What am I going to put on top? What am I going to put on bottom? Because as I said in the last video, I could put real life on top and I could put the map on bottom. It doesn't matter, but you have to be consistent with your 2 fractions that you write, okay? The first fraction is always the scale. So that's what we need down here. You might not even have seen it when you're looking at the picture, but that's the most important part of this picture. 1 centimeter equals 85 kilometers, okay? So if you don't know what these labels are, look them up on Google, but we should know that a centimeter is smaller than a kilometer. So the centimeter must be the map and the real life must be the kilometers. Okay, so we put 1 on, if I'm doing map on top, real life on bottom, then I'm putting 1 centimeter on top, 85 kilometers on bottom. And so if the map tells me that Cincinnati to Cleveland is 4 centimeters, then that 4 centimeters is going to go on top. And what we don't know, if it's asking me to estimate the actual distance between these 2 cities in real life, then we must be solving for the real life number in the second proportion. Remember, you're always going to have a variable somewhere. So you're going to have 3 numbers and a variable. Okay, if we look at our cross products, this video comes with sound effects. We've got 85 times 4 and 1 times x. So 1 times x is just x. So really, to find this answer, all we got to do is multiply 4 times 85, and we get 340. And because we wrote down the labels, I know that my label is going to be kilometers. Okay, it wouldn't make sense to say that Cincinnati is 340 centimeters from Cleveland in real life. We know that's not true. So common sense goes a long way in these two. Okay, you try one story problem, and remember, this is 2 different numbers, and if it's given to you in this form, you want to change it to a fraction and keep them in the right order. Okay, so this ratio tells you that 1 foot to 600 foot. Obviously, if it's a model ship, the 1 is going to be the model, and the 600 is going to be the actual. So that's how we're setting, if we do 1 over 600, that's how we're setting up our first ratio. And then the second ratio comes from the story problem. So read it, try it, pause the video here, see if you can come up with the actual length of the Queen Elizabeth II. All right, and we're back. Model and IRL. Model is 1 foot, IRL is 600 feet, and then they give us a value for the model is 1.6 feet. So that goes on top. Okay, so just match up your labels, and like I said, common sense goes a long way. We know the actual ship is not 1.6 feet long, so we're not going to put 1.6 on the bottom of our ratio, because that should be the real life version. So we're expecting to get, if you look at this relationship here, we're expecting to get something that is bigger than 600, but not twice as big. 1.6 is not quite 2. So it's not going to be 1200. It's going to be somewhere between 600 and 1200. If you can figure out an estimate for what the answer should be before you do the problem, then it makes you feel a lot better when you get your answer and it makes sense. So, okay, so let's look at our cross products. Again, We have 1 times x. That's really nice because that's just 1x. We actually don't have to do any equation solving at all. And on the calculator, when you do 1.6 times 600, we get 960. So just make sure you use the right label. Both of these were in feet. So the Queen Elizabeth II is about 960 feet long. Okay, piece of cake, right? Okay, so you got some proportions to solve, and this is the beauty of cross products. It doesn't matter, just looking at number 8 real quick, does not matter if you have a variable on bottom, because when you use cross products, all the fractions go away. It's a beautiful thing. So, and then this one gives you a hint, put the minus sign on top. In this one, it really doesn't matter. If you put the minus sign with the 1, or if you put it with the 5, those are about the same difficulty, right? It's just a single number. So just put it with one of those, don't put it with both, and you'll be fine. Okay, and then, so you got 2 pages. I didn't dare you to draw anything in this box, but if you want to draw something anyway, I would love to see it. 1 story problem there that you can figure out. And then since you have 2 days to do this packet, there's a puzzle worksheet on here as well as the application. All right, so basically you're getting 10 points for taking the notes. You're getting 5 points for doing the practice problems on these 2 pages, and you're getting 5 points for doing the application, where you got to figure out the answers to these riddles up at the top. So read the directions very carefully. You guys know what to do. Show your work somewhere where you can fit it in, okay? This is probably not enough room for you to accurately show your work and keep track of everything. So copy them down to this page, solve them, and then write your answers up here, and then use your answers to decode these definitions. All right, good luck. Remember, you can ask Mr. Bowman, but you can also email me if you have any questions. I'm happy to answer them. I haven't gotten a single email yet, but I will answer if you have any questions. All right. Good luck, and I will see you for the next video.